Okay, good afternoon, or good evening, I guess, everybody. Welcome back. Seems like we just left. We are in Chapter 2, and we'll continue to stay in Chapter 2 this week, and we'll cover, I think, a concept I told you called sensitivity analysis, which is kind of adding on to what we've been doing. So we're going to solve it, then we're going to look at it post hoc. Like we have a solution, we're going to say how good is this solution, and or is this solution valid? But before we do that, the way I like to start every class, as you know, is to review any of the homework problems that we had questions on. That can include all the homework. I mean, we can do as much as you'd like or as little as you'd like. I'm sure there are some homework problems, homework questions. I really think, you know, part of the problem or part of the difficulty with the beginning of this class anyways is, you know, going through the word problems and formulating a mathematical model. But like with everything else, you know, practice makes perfect, and I promise you'll get better at it. So which of the homework problems would you like to do first? Is there a particular one? Mr. Bear?
I think number 3.
Okay, let's look at number 3. So we do 3A only, right? We're going to do B and C for tonight, but let's look at 3A. Okay, this is on page 102 in your text. So I guess 2 and 3 lead on each other, right? So let's do 2 and then 3, okay? It says, Golden Electronics manufactures several products, including 45-inch and 60-inch TVs. Makes a profit of blah, 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 and $75 on each TV. During each shift, Golden allocates up to 300 man-hours in its production area. So as soon as we see that they allocate this much, we know we only, you know, that sounds like a constraint. We only have limited man-hours. We have 240 man-hours for assembly. Each 45 requires 2 man-hours for the production area and 1 man-hour in the assembly area, whereas each 60 requires 2 man-hours in the production area and 3 man-hours in the assembly area. Okay, so let's do part A, and then B and C we'll do for homework, but let's just do part A right now. So I'm going to set it up here on the board first. Okay, we're going to start with that. So our decision variables are what? This is one we've been doing a lot of them because it's the most straightforward. This is a production mix, right? So we're deciding how many of a product to make to optimize profit. So our decision variables in this case are the number of GE45s to make, and we'll call that X1, I guess. And X2 is the number of GE60s to make. And we are maximizing profit. And it gave me some coefficients there. I think we saw that every GE45, 50 bucks, and every GE60, so 50x1 plus 75x2. Those tend to be the easier ones, what we can decide on, what we're trying to optimize. Now, as we went through there, we heard some things that we cannot control that were constraining us. We only had so many man-hours in the production area, and I think that was 300, so these are prod hours. And we only had 240 hours for assembly. Was that it? Was that the only constraints? Okay, so we need to know now how much it consumes of these man-hours and production hours to make each of these things. So each GE45 requires 2 man-hours in the production process, so that would be a coefficient of 2. And 1 man-hour in the assembly area, so that's a coefficient of 1. Whereas each GE60 requires 2 man-hours in the production and 3 man-hours in the assembly area. And because I can't make negative TVs, I'm going to say X1, X2 greater than or equal to 0. Now, the other thing that you may want to put here, and you wouldn't be totally wrong, but I wouldn't do it, is that GE45s and GE60s are integers. Now, you're right, we're not going to make half of a GE45 and try to sell it or GE60, but you know, they're negligible in the grand scheme of things. You know, if it comes out to be 67.8, we'll make 68 TVs, no big deal. We don't want to add the integer constraint unless we necessarily have to, because you'll see we get the sensitivity analysis tonight. We get some extra information, but when we do an integer constraint, we lose that information. So we don't want to give that away unless we have to. Okay, so I wouldn't put the integer constraint in for this one. So that's how I'd set it up. Okay, that's the model that I would use. Now I want to set it up in Excel. So I'm going to start from scratch, and I'm going to go faster since we've done this before. But if there's any questions, please put up your hand, stop me. I will answer them. And I use the same format all the time, but it doesn't, like some people said they like to go more I kind of go like vertically, but some people said they like it to be more this way. It doesn't matter how you set it up as long as you tell Solver where your cells are, right? You could set it up with labels and colors and everything. It doesn't have to be in one place. I try to use a standard format because I think it makes it easier for people to follow. But I'm not going to nitpick if you don't use that same format. So I'm going to say this is just a label GE45, GE60. I'm going to pre-fill it with 1 and 1 of each. And I might as well, while I'm here, I might as well center things. I'm sorry about that. Hopefully it doesn't go off the table. I'm going to maximize my profit. And I have 50 and 75 are my coefficients. Is that an alarm maybe? What's it called? Okay. So I'm going to use sum product, and sum product's nice because one function is going to multiply C2 times C4 plus D2 times D4. So I'm going to give it those two arrays, C2 through D2, comma, C4 through D4. I know I'm going to reuse this formula, and I know every time I want to reference those decision variables, so I'm going to make the first component static. I'm going to put F4 there. Okay. So it looks like it's working right. 1 times 50 plus 1 times 75 is 125. Let's see. Going to skip a line. Subject to. I'm going to put production hours here. Oops. PROD. PROD hours. And I want to concentrate on my coefficients of 2 and 1. Let's copy this down. And we're saying that has to be less than or equal to 300. And for assembly hours, okay, we have 2 and 3. Copy that formula down. And that has to be less than or equal to 240. Now, one of the difficult problems using Excel is, sometimes you solve it and you just don't get an answer. It says, couldn't find a solution or whatever it might be, or you get the wrong answer. What I always like to check even before I go into Solver is I want to make sure that everything changes. As I change the decision variables, the profit I make and the things I use change accordingly. Okay, that's telling me I have things set up correctly. So now I want to tell Solver about these items. I go up to Solver. First wants to know is what am I trying to optimize? In this case, I'm trying to maximize cell E4. My variable cells are C2 through D2. I'm going to add these two constraints in one, so I'm going to say add E6 through E7 is less than or equal to G6 through G7. Click add, then cancel. I should see it up here. Make unconstrained variables non-negative. Very good. That's putting in that last constraint for me. And I'm going to say simplex LP. I click solve, finds the solution. I'm going to click OK. And it looks like the best solution right now is to make 80 GE60s and no GE45. Is that what you guys found? Is that the answer? Yes? Okay. Let's go to part 3, or number 3, right? It says, suppose that management at Golden Electronics has decided to do extensive testing on every TV to ensure its quality standards. Each 45 will require inspection time of 30 minutes, and GE60 televisions require 45 minutes. And it looks like we have 80 hours of this inspection time. So what is that? That inspection time is another constraining variable, right? We only have 80 hours. So I'm going to add that over here. This is inspection hours. And I believe I have 80. So I'm going to copy that down. I'm going to put 80 here. Now, the difference with this one is it gave the coefficients in minutes. So it told me that each G45 takes 30 minutes and each G60 takes 45. So I don't want to put 30 and 45 in here, because anytime I have an equation, I want to make sure the sides match one another, right? So I have minutes on the left side and hours on the right side. That's a bad thing. So I'm going to put all this in terms of, well, it doesn't matter how you do it. How'd you guys do it? I can put it all in terms of minutes by multiplying this 80 by 60 and get, what do I get, 4,800? Whoops. It's 4,800, yes? Okay, or I could have left the 80 there and changed it to 0.5 and 0.75, okay? Now, if I resolve, it's going to give me the same answer. Okay, and the reason it's going to give me the same answer is I didn't tell solver about my new constraint. It's up here, right? It's modeling it. Okay, it's modeling it, but I didn't tell solver about it. So I need to tell solver about it. So I'm going to go up here and say add another constraint that this, which is the number of inspection hours, inspection minutes, I guess, used, has to be less than or equal to this. I click solve. Okay. It gives me the same solution. Did you guys get the same solution?
I think that the first one was the solution says 105 GE45s and 45 GE60.
Well, you flopped your data's wrong. So
Fix it for me, Adam. What's the right one?
Right. So hours of production.
Yeah.
For your 45 should be 2 per 2.
Okay.
And assembly is 1.
This is 1.
Correct.
Okay.
And then it's 2, 3 for the 60.
Okay. So this is right now.
Yeah.
Okay. All right. So let's go back. Let's resolve it then, part 2. And I'm gonna delete that last constraint because that's all we really added for part 3. So I'm gonna delete that. And I'm gonna click solve. And there we go. So now I have 105 and 45, right? And that makes me $8,625 worth of profit. So that was the answer for 2. Is that the right answer now? Okay, it didn't feel right. Let's look at part 3 then. Now for part 3 it says we're going to constrain this item further, and we're going to say we only have this many minutes, so E8 is less than or equal to G8. Now before I solve this, I know I'm going to make less money in this solution. Why? Why do I know I'm going to make less money? I'm not going to make $8,625 when I resolve this. How do I know that? Before I even solve it. Yes?
Because you're making less.
I'm going to make less, and anytime, think about visually when we talked about what we're doing. We're picking, okay, remember the feasible region? These are all the points that are feasible. If we add a constraint on it, right, we're never going to make more, right? We're constraining ourselves more. So when we add constraints, we're taking away values. Sometimes they're the best values, yes? And in this case, we know we're going to take away values because, hey, in the old solution, we used more minutes than we had. We're not going to be able to use that many minutes, right? We only have 4,800. So I know it's going to constrain itself, and it's going to choose an option that's less attractive to me. I click solve, and it does give me, as you guys pointed out, now I get 80 and 53. Is that the right answer? Okay. And my profit went down, did it not? Because anytime I add a constraint, I'm constraining over, I'm reducing my number of options, especially if it's a binding constraint. And that was what's called a binding constraint. It's holding me back. let's hold on to that one. I'm gonna save that one, and when we talk about sensitivity analysis, we're gonna use this one as an example. Okay, so if you guys did that with me, save it. I'm just gonna call that chap GE45, GE60. We'll come back to it. Might as well save it so I don't lose it. Oops. What others would you like to do?
$17.
17? Okay. I'm glad you said 17 because a lot of the ones we've been doing so far have been these production mixes, like manufacturing type examples. You know, corn and barley, that's production mix. How many of 45-inch TVs, how many 60-inch TVs? We can also use this for different types of models, and one example is something called a portfolio model or investment model. We all have investment portfolios. Maybe it's not where you want it to be, but you have X number of dollars and you have that apportioned across a few things. Maybe a checking account, maybe a CD, maybe gold, maybe Bitcoin, you know, venture capital fund, whatever it might be, right? And we want to try to pick an optimal mix based on the person. And a lot of times what is an optimal portfolio for me isn't the same as an optimal portfolio for Dylan, right? I'm gonna retire a lot sooner than you, hopefully, right? So, you know, I wanna be less risky. So we oftentimes, if you are like a certified financial planner, some of you guys may be financial planners, you need to find out about what your client's investment goals are. What do they, and their tolerance for risk, and all these things factor into it. Now this is kind of a simplified model, and we get these things get a lot more robust later, but this is a good introduction to it. So this is George. George Rifkin is considering investing some or all of a $60,000 inheritance in a 1-year CD, paying a fixed 6%. CDs don't pay that anymore. They're about 1 year is about 0.5% now, I think, in most places. Or a venture capital group project with a guaranteed 3% return, but the potential of earning 10%. George would like to invest the minimum amount of money, that should be money, not month, the amount of money necessary to achieve a potential return of at least $4,000 and a guaranteed return of at least $2,000. Formulate a mathematical model and recommend an investment strategy for George. How much of his $60,000 can he keep for his personal use during the year and still meet his investment criteria? Okay, so let's think about this as far as our 3 things go. What are we trying to decide with George? What is George trying to optimize? And what are the requirements? What are the have-to-haves? Basically, George gave us his investment goals, his have-to-haves, right? So what are we deciding? What are we deciding for George? Dylan?
What to invest his money in?
Okay, so I'll say CD means the number of dollars to invest in a CD, yes. And VC is number of dollars to invest in a venture capital fund. All right, that's right. So that's what we're deciding. How much goes here and how much goes there, yes? What's his goal here? What's his goal? You could look at this a couple of different ways. You could say, I'm going to maximize my potential return. That's one way. You could say, I want to minimize risk. They don't really bake risk into this. But what's he trying to maximize or minimize? What's the thing he wants the best of? Returns. Not returns, because his returns, obviously we all want good returns, right? But there's things that he has to have, and there's things they say, given that I have this, I want to optimize something else. What does he want to optimize? What does he say he wants to, what's to do? What's his goal? He has to have the 4,000 and 2,000. So when you have to have something, and he does, that's going down in my constraints. That's a requirement. He has to get that 2,000 and 4,000.
Wants to maximize his monthly spending out of his 60 grand.
Okay, so he wants to invest he wants to keep money as much as he can, right? He wants to do whatever. He wants to stay liquid, yes? So he wants to minimize whatever he's putting in these two funds, right? He's trying to minimize the total we invest. So he's minimizing CD plus VC. He doesn't want to, he wants to get those returns at 2,000 and 4,000, but he wants to minimize how much he has to put in to get those, right? He wants to minimize that. Does that make sense? Because he wants the rest is walking around cash. All right? Subject to. All right, subject to. So the other things, you're right, potential return is something that he wants, but he just said, I want at least $4,000, or I think it was potential return. Yeah, it was at least $4,000, and a guaranteed return of at least $2,000. So he wants at least $4,000 for his potential, and he wants at least $2,000 for his guarantee. Now, with the CD, what is every dollar he gets, he's going to get what off every dollar? 6%, yes? So if he invests $1,000, that's $60. If he invests $10,000, that's $600. So that looks like 0.06 CD and 0.06 CD, because a CD is a CD, right? It's guaranteed up to FDIC insured through the the grace of the United States government through I think up to $250,000. There's no risk there, right? As long as the federal government doesn't crash. Okay, so that's guaranteed. So that 6% is guaranteed, and this is potential. It's 6%. It doesn't matter, right? The venture capital fund, the potential for that is 10%, right? And the guarantee, which you don't get guarantees with venture capital funds usually, I think was 3%. Is that what I heard? Okay. What else? What else? I don't even know if the book put this in, but what else do we need to think of here? So he needs to get these returns. He wants to minimize an investment. CD and VC are the things he's investing. What else?
He only has 60,000 to invest.
Very good. So how would I write that, Eric?
So it would be CD plus VC has to be less than or equal to 60,000.
Very good. Right? Because if he had some crazy numbers over here, right? Like he wanted a guaranteed return of 20,000, a potential return of 40,000. If I didn't have that constraint in there, it would say, all right, put 80,000 in here and 60,000 here, and you get it. And you're like, whoa, whoa, whoa! I only have 60,000, right? I have to put that in because that models reality. Yes, he only has 60,000 to invest. I know he wants to minimize what he's putting in, but reality is that's the most he can put in as well. Does this make sense? Okay, so what I'm going to do is I'm just going to copy this tab and start a new tab because I already have the formulas in there. So I'm going to right click on that. I'm going to go to move or copy. I'm going to say create a copy and click OK. And then I'm going to rename that tab to Rifkin. I also like the fact you can color these now. This is money. Let's make it green. All right, give it a green tab. Okay. All right, so I'm just going to take this and rework it for this situation. So I'm going to change this label from GE45s to CD. I'm going to change this from GE60s to VC funds. Okay. And I'm going to just put 1 and 1 here. And I am minimizing. And remember, we're focusing on coefficients. What's the coefficient here and coefficient here? Even though they're not written, what are the coefficients? 1 and 1. Okay, so every dollar invested in a venture capital fund and a CD is a dollar that George doesn't have to play around with. Let's look at potential return. So we're going to say potential. Is that the one I did first? Yeah, potential. And the coefficients are 0.06, oops. Coefficients are 0.06 and 0.10. And I don't have to change that, but I do have to change this direction. That's greater than or equal to 4,000. And this is my guarantee. And that is 0.06 and 0.03. And it has to be greater than or equal to 2,000. And my total is 1 and 1. Has to be less than or equal to 60,000. Now I haven't told Solver about any of this yet, but let's just see if I change cells. If everything is changing, yeah, sure. Invest in $20 here, 10 and 10. My potential return when I invest those $20 is $1.60. My guaranteed return is 90 cents. Okay, not very good, but accurate. And I'm invested $20. So everything looks like it's working here. Does that make sense? So let's tell Solver about all these things. So I'm going to go up here to Solver. It says, what is your objective cell? Well, it's still E4, but what about E4? What do I want to do with E4 in this case?
Minimize it to the max.
Very good. So I'm going to click the min option button. My changing variable cells, yeah, they're still good. C2, D2. I'm going to delete these constraints because I'm going to re-add them because I don't, Okay, so I'm going to delete those constraints and start over. So what's nice is these first two are going the same direction. They're both greater than or equal to. So I'm going to add them as an array. I'm going to click on add, and I'm going to say E6 through E7 is greater than or equal to G6 through G7. And I'm also going to say E8 is less than or equal to G8. So let's just make sure everything looks good. I'm minimizing E4, great. By changing C2, D2, fantastic. E6 through E7 is greater than or equal to G6 through G7 respectively. E8 is less than or equal to G8, that looks good. I'm saying can't invest negative dollars, and I'm using Simplex LP. I click solve. It finds a solution for me. Might as well make that currency while I'm in here. And it's saying that George should invest $19,047.62 in a CD, $28,571.43 in a venture capital fund for a total of $47,619. He'll still have roughly $12,400 to walk around with, and he's meeting his investment goals. Okay. What if George was not a realist and he came to you and he said, I have $60,000 to invest, and I want to invest in this CD in this venture capital fund, and I want a potential return of, let's change that 4,000 to 40,000. Now let's change this guaranteed return to 20,000. And I resolve it, and Excel is going to give me a different message. It's telling me Solver could not find a feasible solution. What this is saying is, hey, given the amount of money that you have to invest, there's no feasible solution that's going to get you a guaranteed return of 20,000, a potential return of 40,000. Now, if I remove that last constraint, and why not, let's do that. If I remove that last constraint, and I resolve, now it will give us a value. And if you ever see these like all these pound symbols, what it's saying is, I don't have enough room to show you what's in there, so let's see what's in there. So if I double click on it, it'll expand, it'll auto fit the column. So it's saying if you want a $40,000 potential return and a $20,000 guaranteed return, well, you have to invest $190,000 in the CD and $285,000 in the venture capital fund. So obviously, when we add that $60,000 constraint in there, it violates it, and that's why it says not feasible. I removed it, it says, all right, yeah, this is what you have to do, but it doesn't match what George, he has, champagne taste and a beer budget, right? So it's not feasible in his situation. So I'm going to go back to the original formulation. So was that the end of the question? Was there anything else in there, Adam? Was there something like what was there a specific area of that problem that he was giving you some difficulty?
Yeah, I mean, I just couldn't separate it. I thought Excel would have been able to create a value in the cell that was the optimal percentage in between the 3% and the 10%. I thought there would have been a way to.
You mean right here?
Correct.
Something in there.
Underneath the venture capital fund.
It's kind of what we're doing. We're saying that each fund has a range, right? It has a guarantee of 3% is the bottom, and a guarantee of 6%, and the CD has that range is 6%, 6%. It's always the same 6%. The venture capital fund 3 to 10, right? So, if I change those 4,000 and 2,000, it would change my makeup, right? And this happens every day. Like if anyone's ever gone into a financial planner, I don't know if anyone has, but they ask a lot of questions, about your goals. When do you want to retire, and how many kids do you have, and what's your retirement fund like at work, and what your insurance is. They also ask you like what's your aversion to risk. They ask personality questions because some people are fine taking a loss, knowing, hey, maybe in 5-10 years this will pan out for me. But some people that doesn't, they panic as soon as they have a loss, and they want to pull out their money. And those kind of people don't want to invest in like high volatility kind of things. So they put them in more, more conservative type investments, more guaranteed investments. So that's what a good financial planner is trying to do. He or she is trying to design a portfolio for you that matches your goals, but also matches your investment strategy and your personality as well. Okay, and this is a simplified version. Obviously, there's a lot more to it. Like we don't have risk involved here. Obviously, the CD has no risk, and but we don't have a lot of risk involved here. But there's things called beta and everything else when you look at financial models. It gets very, very complicated very quickly. But fun. What else? What were the others? So we did 2, 3, and 17. I don't know if there were any others that you guys had questions on or struggled with. Is everyone? How's this going? Are we getting these? Have to check the solutions, or we're getting them right away. Like I said, it's like anything else. Think about that corn and barley one that I gave you at the very beginning of class 1. And you guys, I think maybe one person came up with the solution through trial and error. Now that'd be easy for you, right? That's like a big softball floating down the middle. We get better, right? Every week we get better. And truthfully, this week we stay in chapter 2. We stay in chapter 2. We add on to this concept, but we're still going to do these 3 things. We're going to look at these problems, and we're going to say, hey, what are the decision variables? What can we control? What are we trying to optimize? What are we trying to maximize or minimize? What's holding us back? What is constraining us? What do we need to adhere to? Okay? And I think that's another way of thinking about it. I used to work for M&T Bank, and I was a project manager in the technology division. and it was a crazy exercise, and it never worked like we wanted. But we used to tell our clients, which was internal clients, they were bank clients, we said, what are the, we used to say, I want you to rank the time, the cost, and the quality of this project, right? You need to rank them, 1, 2, 3. You know, what's the most important to you, what's the least important to you, and what's the middle important to you? And what we would say is, like, if time was most important, right? Okay, that's like a must-have. That would be in the constraint. Like, we have to make this deadline, yes? So we'll try to do the best job we can, but it may cost you more, right? Because we need to put more. And if they said, you know, the quality is the most important, you know, that's the must-have. It has to be perfect. Well, it might take more time. It might cost more money, right? And if the cost was down here, we say, oh, okay, we'll get it done for this, but it might take a while, you know, and the quality might not be great. It's kind of a crazy exercise, but that's how a lot of things work in life, right? You have, you know, there's one thing you can't get everything. You know, it's called, in project management, that's called the iron triangle, because changing one affects the other, right? Okay, Dylan, you had your hand up.
It goes back to that first question.
The GE45s?
Yeah.
Yeah, okay.
Just the minutes and the hours, it doesn't
Yeah.
matter which way you go.
Great question. Let's do it. So this is all in minutes right now, right? Let's change it back to hours. So that would be 80 hours. That's what it gave it to us in. And 30 minutes is 30 divided by 60. That's 0.5 hours. And 45 divided by 60 is 0.75 hours, right? So if it doesn't matter, we should be able to resolve it and get the same answer. So let's see. Data, solver, solve. Solver found a solution, and it's the same solution. Okay, so yeah, it doesn't matter as long as it's balanced. Whatever's on the left-hand side has to equal whatever's on the right-hand side. You can't have minutes and hours and hours. You know, it has to be apples and apples, oranges and oranges. It can't be different. It can't be mixed. Okay. So any other questions on the homework? Okay.